Thank you for all skipping the Facebook talk to come to this one instead. If you were hoping this was the Facebook talk, you want to go next door. Wow, no one left. Awesome. So we're talking about resilient messaging. So this is a little bit of an update from one that Scott and I did last year. So we're going to update some material around the JBoss A-MQ 6.1 release, which I don't think has been officially announced, but if you happen to go to jboss.org/JBoss A-MQ, you might see it. I don't know. But so we'll talk about some of the new 6.1 features. I'll talk a little bit about some of the Fabric stuff if people were here for yesterday with James Strachan and Rob Davies talking about Fabric 8. You'll see a little of that. And then, so I'll talk to the agenda. So I'm going to quick update, talk a little bit about some of the updates in Fabric 8 around how it's doing HA. And then Scott's going to talk about some of the Red Hat high availability and how that can play as well. So we're looking at two different ways to do ActiveMQ sort of high availability setup and kind of look at it from two different angles with a little bit of an overview on what AMQ is if you don't know what that is.
Developers and operations.
Developer and operations. So that's what we're hoping to do. I don't have a timer, so I'm realizing I don't want to run over your cycle. So I'll peek at my phone every so often. So this is me. So I'm starting the talk. Really, this slide's all about just pointing out the fact that I've got my Camel book out, so you guys can all buy it. I'll be talking about that more this afternoon. But I've been dealing with, I came over into Red Hat as part of the FuseSource acquisition, so I've been dealing with Fuse and AMQ, ActiveMQ for about 5+ years. So that's sort of why maybe you want to listen to me. But so I've been dealing with this for a long time, helping a lot of customers be very successful with that. A few of you are here, which is awesome. I don't know why you're still in the room because you guys have been successful with this, but why you need to learn more. But we're hoping to do, anyways, that's who I am. So the AMQ product from Red Hat. So a lot of what I'll be talking about is sort of ActiveMQ, Apache ActiveMQ. So everything I'm going to mention is you could use the open source community version and do some of the same things. We package that up at Red Hat into this. So the ActiveMQ HA options I'm going to talk about are still relevant. This is layered within our thing within Apache Carafe and what's now Fabric 8, which is the upstream project that we've renamed. It was Fuse Fabric before this week. So we'll talk about that option as well. So that Fabric is, well, I'll talk about it. And I just put this in the portfolio. This is confused people, so I'm just putting this. Sometimes you'll hear me reference Fuse. So AMQ is the subproduct of Fuse, which is now there's a Fuse ServiceWorks, which adds governance on top of that. So if you hear this, just to give you some context. Okay, enough of the product-y stuff. So what is AMQ? So I like to start with customer references and just talk about where people use it. So FAA is using this. So if you flew here, Fuse ActiveMQ actually helps support you, which is kind of cool. FAA has this deployed. They're about 6 years into usage of this, about 3 years into production, around distributing like weather, runway information, control tower event data nationally. So they have ActiveMQ deployed across 20 data centers nationally, distributing this information across the airlines and airports. They've got one of the programs they have it deployed. It's a 5 nines available system, and they've got a 30-second guarantee that a message has to be delivered even in the event of an entire data center loss. All on ActiveMQ, which is really awesome. And it's in production. That's why you're here today flying. It's all cool. And this was a picture that came out of Linda Chen from FAA talked at the Camel user conference back in 2011. And so she put this slide up talking about sort of where SWIM is the system-wide information management system. So this is the tier that Fuse and ActiveMQ are deployed within in terms of distributing out this weather and control tower event data. And they're using that as part of their effort to modernize a lot of the air traffic control system nationally. So a really, really cool example. There's still a video if you go to camel1.org. There's still a video of her talking about this, as well as a bunch of other people talking about their use of this technology. So it's a cool thing if that's an interesting area for you. You can see them talking about their usage of it. So that's sort of roughly how people have used it. In terms of what it does, in terms of ActiveMQ. How many people have used ActiveMQ? Do you guys all know it? You all use recent versions? Old users, new? How many are doing the brand new stuff, like ActiveMQ 5.9? A couple. So older that. Everyone else is sort of 5.8, 5.7. Anybody using ActiveMQ 4? Oh, good. I feel really bad for you. Yeah, so then you most of it know it. So with the update on 6.1, so I'll touch on some of the new things. So JBoss A-MQ 6.1 is based on Apache ActiveMQ 5.9 that's out there. So it's added official support for like AMQP 1.0. It's a some of you guys know this, it's a multi-protocol broker, which is its big value. Deals with a lot of different languages and stuff that you can tie into it. You can have a lot of different protocols. So AMQP and MQTT are sort of the hot protocols that people have tied into. There's of course another talk going on right now talking about Internet of Things. There's a couple of talks on that actually. There's another one, James Kirkland's doing one later this week as well. So they're talking about some of the usages of ActiveMQ around energy and transportation networks. So some of that's MQTT and AMQP are playing a big factor in that. So there's some cool things around that. Okay, that's my very quick about, so what are the protocols and things? And then in terms of scaling, so now coming back to the, hey, wasn't this all about HA and scale out? Hey, okay, so we're gonna talk about that. So generally, a lot of ActiveMQ, people can scale it, vertically. You can kind of throw really more I/O at it. It's not so much a compute-intensive system. So if you throw faster disks, so reliable messaging, I'm kind of assuming, particularly since so many people raise their hands with ActiveMQ, reliable messaging is really about the guaranteed delivery. We're going to take the message, put it off of the secondary storage. So if the broker dies, and you restart it, the message still gets delivered. Hey, it's a good thing. So scaling is much more of a factor of the I/O subsystem. In terms of vertical scaling. And horizontal scaling, that's where this idea of network of brokers, which is the ActiveMQ concept, you can stand up multiple brokers and establish a network connection between them. So it'll store and forward the message across it. And that's how you can sort of get horizontal scale out. You can add really more, it's more about how many clients can connect to it in terms of how I want to horizontally scale it out. Again, because it doesn't tend to be a compute intensive piece of software. It's more, again, I/O intensive. And Fabric 8, really, which is the new upstream project for Fuse Fabric, is bundled in, and that helps with some of that configuration management and scale out as well. So it can help you, instead of manually coding up, so if you guys have done ActiveMQ and the ActiveMQ XML file, you'll have like the network connector, and you have to point it to a host and port of somebody else, and you have to make sure there's a transport connector set up on that one and do it. So Fabric actually will do all that for you. So you could just say, hey, I'm going to create a broker node. I'm going to call it, Fred. I'm going to create a second broker. I'm going to call it Joe, and I'm just going to tell Fabric, hey, Fred needs to be networked to Joe. And when it stands up the broker, it automatically wires all that together for you. It will do dynamic port allocation and host assignment, which is all kind of cool. And this helps us scale out in terms of and now people looking at OpenShift and OpenStack and all these elastic scale environments, the fact that the hosts are moving and the ports, it all is sort of taken care of for you, which is kind of cool. So that's why I'm talking about Fabric. And this is sort of the picture version of what network of brokers is. This is the idea that I could have two brokers. They're independent. So this always tends to be a point of confusion. At least a lot of people I've talked to is they think, hey, I've set up a network of brokers, so I've got fault tolerance. No, if a message is in one particular broker, the message is still there. If that broker instance goes down, the message is still safe in the store, but it's not going to be dispatched to anybody. A network of brokers is only there if I've got clients, say, if I'm delivering messages in the head office and I've got consumers in the remote office, both those instances have to be there, and that network connector is going to allow the messages to be routed from one place to the other. But the message is only going to be, in one spot at one point in time. So it doesn't actually get you fault tolerance in that sense. It gets you scale out, which is good. But if the broker instance is down, your message isn't going to get delivered. And that tends to be one point of confusion for a lot of people, is that the different concepts. Okay. No one's arguing with me. That's a good thing. So what do we mean in terms of reliability? So like I said, and I always like to point this out, it's like the broker itself, just as a standalone node, is resilient. If the broker puts the message out in secondary storage, it's safe. The process dies, comes back. As long as the secondary storage is safe, file system, database, the messages there will be delivered when that process is restarted. That's a good thing. Simple. You can just do a process monitor on the thing and you're good. Have it sort of restart the process on the machine. Awesome. Master-slave kind of environments that we do is shared something. So shared file system or shared database. You're coming into it. So now it's the idea that I'm going to set up a secondary node, a passive node, that's going to detect that a failure's happened. Out of the box with Apache ActiveMQ, that detects something bad happened is there's a lock that's released. So if you're opening it up on a shared file system, we're assuming that there's a shared distributed file lock that exists across the system, which is why I've got the little point about like NFS4. Please don't use NFS3. NFS4. NFS3 has an issue that it won't release. Most of the time, it won't release the lock. So if the master process dies, it won't actually release the file lock more often than not. And occasionally it hiccups and you get both go active and you get corruption. So NFS3 bad, don't do that. NFS4 we've had a lot more luck with. Customers have had a lot of success with that, and the locks transfer correctly. Relational databases, we do table locking on that. So that's how Apache ActiveMQ will do master-slave, is it will use that file or database lock as the indicator. So the slave is basically polling for access to that lock. Can I get access to that file? Can I get access to that table? And it just sits there and waits. And if the master dies, that lock gets released, and that's how it kicks off. And that's awesome. You can also do things with replicated, like block level storage, or I've seen people do like Golden Gate or other things with terms of relational databases. So this, you can do that strategy as well. So you're not depending on a shared file system or access, but you've got to ensure that there's synchronous replication across the system. Because we've had people ask about the idea of can we put like ActiveMQ or Cassandra, one of these replicated databases? Well, we could, but generally people with these kind of things, these messages tend to be very short-lived. People like, I want to deliver the message. The happy path for most messaging systems is the consumer's there, the message is delivered immediately. Well, in these replicated systems like Cassandra and things, it's the eventual consistency. Well, eventual consistency in these kind of reliable messaging is bad. Hey, maybe I get 4. Maybe I sent 5 messages. Well, maybe 4 on the other side. Hey, that's cool, right? You're okay with that. Strict order of delivery. Yeah, who cares about that? That's not that important. So these eventual consistency environments don't work. Or if you do, you can do a synchronous like block level replication, as long as you're willing to tolerate some message loss. So generally, synchronous is going to give you sort of guaranteed, but it's going to slow your system down because that whole laws of physics thing. The electrons still have to go to the other side, the other data center, or wherever. You could do asynchronous if you can tolerate, if you knew you could tolerate the loss of the last 10 seconds of messages or 30 seconds of message, you could put some asynchronous replication in. Depends on your environment. So those are good strategies that work. They work. They're very vanilla. They're very simple to set up as long as you kind of understand what's going on. And you could also do with a replicated, there's also an assumption that there's some sort of management happening. So something is actually making the determination of who's the master. So I'm replicating the persistence store, the message store, which is where your data's at. That's safe, good. But somebody has to decide which process is going to be active. So this is something like Cluster Suite, how Red Hat High Availability can play, or any other kind of strategy, which is obviously not as cool as Red Hat High Availability. But if I've seen people use like IBM HACMP or Veritas or other things to do that kind of process management. So this system's live and I can fail it over. That makes sense? And then we'll talk a little bit about Fabric. So this we talked about. This is the picture version of what I was saying. Everything's safe, producers, clients, messages. As long as that process is running, message will get delivered. Shared storage is the other option I was talking about. So now we've shared something. So again, your message store is shared. There's something acting as a lock manager between this system. So either sort of a passive lock manager, again, this distributed file lock, or a lock on a database, or again, something like Red Hat High Availability. And then the big fancy picture of Fabric. So what Fabric, or Fabric 8, the open source project, is doing is it's now acting as a more active lock manager around the system. So when we kick off an ActiveMQ node, it's actually coordinating with Fabric acting as a runtime registry. So it now, like I said earlier, Fabric actually can allow you to build out logical names. So I can go create a broker instance, I can give it a logical name, I can establish network connections between them using logical names. So what Fabric is doing is it's tracking in terms of its runtime registry. It's knowing, hey, here's the host number, here's the host name, here's the port of that ActiveMQ instance that's running. And the clients coming into it can go access that registry and say, where is it? And then go connect to it. Or other brokers can go access that registry and say, hey, I need to establish a network connection to some other broker. Where is it? Give me the host and port number for it. So that level of indirection is kind of cool. That also allows it to decide when to make masters, the master-slave thing. It can decide when it's going to be active, when it's not. So again, it's deciding to do that. What's cool about that is that means that now for those shared, if I had a shared file system, I don't have it in my picture, I don't think, no. If I had a picture of, say, like 2 nodes running off of the same, like a shared file system, it allows me to do stuff that I don't have to have a distributed file lock. So I could do NFS3. I could do other file systems. I could do replication, because now there's something else that's making the determination, hey, this process is the master. Or it just went away, so now make the other one the master. I'm not depending on a file lock. So it gives you options, which is a good thing. So you can use different types of file systems or different strategies around how to deal with the data, data moving between places, which is cool. You can also interrogate the system and ask it who's the master, which is another good thing. So you can actually kind of force failure back. I want you to be a master. I want you to be a master. So you can decide where you want the machines. A lot of customers want, certain, when the broker is running, they want it running on a particular place if possible. I want it running on this machine. I want it running in this data center if possible. But if it fails, I want to go over here. And then as soon as I can, I want to fail it back to this particular spot. So this gives you the ability to ask something who's running, as opposed to kind of poking at a machine and saying, hey, who's got a, does ActiveMQ have an open transport connector? And you have to poke all the different machines to try and find, find the master. Because that's how Apache ActiveMQ will do it, is it won't start the transport connections. The slaves won't accept client connections. I think there's actually a JMX metric now that you can ask, but that was the old way of dealing with it, is that you had to go, can a client establish a connection to this process? And that was the only way to kind of figure out who's master and slave. Kind of sucks. So in now the new Fabric management console, so this is a picture, and I'll show you a demo in a second. I think this is my last slide. I'm moving along. So the new Fabric 8 stuff that James and Rob were talking about yesterday that are now part of 6.1, which has not been released, but again, if you look on jboss.org, you might find it. And maybe you'll hear something about it tomorrow. I don't know. I didn't say that. There's new options in terms of Fabric. So Fabric before would allow you to build out like master slaves and things. There's a new wizard. So that's what this picture here is. There's a wizard in the Hot IO console. So if you were just at Stan Lewis's, extending Hot IO is the management, the web console framework for this. So there's a new cool wizard in this that basically, again, helps you build out what you would have hand-coded in your ActiveMQ.xml file. So I can now use this wizard to do a bunch of different things. Like, let me just switch. Let me switch. Let me show you to you. So this wizard, you can see it. So I pre-built something out just because I didn't want to go through the dance of, hey, the Wi-Fi is slow, and I can tell my not so funny jokes and wait for the thing to finish. So I'm going to have pre-built it out. So there's a couple of things going on in this window. So there's a MQ tab. You can create a broker. I'll show you the wizard, and then I'll show you the end result. So this is the new wizard page that comes out of it. I can give you the kind of walking tour. So you can establish groups, little tooltips. Hopefully I'm going to say the same thing that tooltip does. So this group name allows you from the client libraries so that you can use, again, this logic name. I can say discovery fabric : logical name, group name, and I could have one or more active brokers running inside of that group name. And the client is going to load balance across that. So I could say have 2 brokers with a network connection established between them, right? I'm scaling it out. And I could give it a logical name, like DevNation, like I did in the last one. Hey, look at that. Well, I could have a client, I could have my applications, I could set up for the connection URI. I could say discovery : fabric : DevNation. And it's going to round robin it. Some will go to broker east, some will go to broker west. And I could add another broker to it. I could add a broker north. And the clients will just start, it'll automatically start round robbing. I don't have to touch any of my application configuration. All my clients, I can just leave them alone because they're referencing that logical name, and they will automatically pick up the fact that I've added brokers, I've removed them, I've moved them someplace else. Awesome. I could also reference the individual name, so I could connect things specifically to broker east or west if I wanted to, again, through logical names. And that's, you can also do that right on here. I'm probably not going to get it. Yeah, you can't really see that right at the bottom. You can actually establish network connectors, again, through those logical names. So I could say, you know, broker east is network to broker west. Or I could associate it to a group. If I had 2 different groups, say east and west, for like data center east, data center west, I could just put a definition and say network east to west. And then all of the brokers in that east group would establish network connectors to all of the brokers in the west group. All of them. So it kind of meshes out. Cool. So you can kind of play games with all of this stuff. And again, as the system changes around, you can take advantage of that. Again, this becomes more important again as we get into like platform as a service, and so these elastic scalar architectures. The fact that we've now got that indirection allows us to play games with, we're going to auto-assign ports, we're going to auto-assign hosts. Now my applications don't care, don't know, and I can do all kinds of cool things. Even if you're not doing that, James was talking about microservices architectures. Even if you're just building out those kind of environments, I'm going to spin up this little tiny processes running places. Well, great, that's cool too, because I don't know, I don't care. I'm going to spin up more of them, less of them, have ports assigned, awesome. It's just going to figure it out from logical names, very cool. The other things going on, you know, the broker name is still the broker name like in the ActiveMQ.xml. Now we've got a little wizard. There's also a wiki page, so you can actually self-documenting. Hey, look at that. There's our documentation. So we can do things like, so n+1 is what I've set up, and I can talk you through that a little bit with a bigger picture, but we have an n+1 structure. I'll talk a little bit more about that in a second, because that's what I pre-built out. There's also a replicated, so there's a new, in 5.9, so the 3 people who raised their hands with 5.9, maybe you know this. So replicated LevelDB. So LevelDB was a new persistence store that was introduced in 5.8. It's based on Google code. I always forget the name. I think it was Big Table, but LevelDB was coming out of a Google project. It's a very fast journaling store. So we built this new adapter on it. We found that gave us some advantages. It had some better mechanisms. So things like topics, JMS topics, particularly if you're doing durable subscribers, tended to do a lot better. It tended to reduce the I/O throughput per message coming into the system. So we got about a 50% bump in just total throughput that you could get into a LevelDB store. So some of the tests we had done on one environment, we had like KahaDB, which was the previous one for the last bunch of years. We were getting up like 8,000 messages a second on some particular system. We might get up to like 12 to 13,000 with LevelDB. So it was a pretty significant throughput increase. So within 5.9 now, there's a new effort to build out this replicated LevelDB. So we've built in replication technology. So we can stand it up as a quorum. So you have to deploy 3. So there's sort of a controller. Well, there's a leader election, so one becomes the controller. There's 2 sort of other members of the group. You have to have a zookeeper running, which like Fabric Registry is based on Apache Zookeeper. It's acting, again, as this lock manager. As messages go into it, LevelDB ensures that the message is put into the current leader and one of the other ensemble members. So that way, if you lose something, there's somebody else has that message. And it goes through leader election after that, and somebody else becomes a leader, and it carries on. But this means you don't have to have shared file store, you don't have to share shared database, you don't have to put in your own replicated whatever stuff. It's doing it for you. So it's the beginnings of our sort of a shared nothing approach, which is very cool. It's brand new. Caution. It's brand new. It's brand new as of Apache ActiveMQ 5.9. So there's a lot of people very eagerly looking at it, but it's going to take some more hardening before I would suggest, hey, everyone go out and download it and use it. Maybe you want to play with it. Good. But I'd hold off a little bit before you go into production with it. Maybe get another point release out in the community before you do it. Bug fixes, a few more. But it's very promising, very cool. So we're seeing a lot of excitement, and we're definitely going to pursue this more. In the Red Hat version of this, the JBoss A-MQ thing, we're listing this as tech preview, which is our official way of saying, hey, play with it, but ooh, maybe you don't want to go to production on it. Think twice about that, because it's going to take some hardening. But we're definitely going to see a lot more investment in the community on this. So in terms of, and I won't talk about the other, and just so that way I can give Scott some time. But so what I built out here, I was playing with it. I'm happy to show people later. I just want to make sure I give Scott some time to talk about the cluster suite stuff, because what am I doing for time? Hey, I should get off. So what I built here is, this is sort of a picture version. I built out 2 profiles. So a profile is basically like ActiveMQ referencing a particular persistent store. So it's like, data directory 1, data directory 2. And there's got a network connection between them. So that's what these profiles are up above, which in Fabric translate to these scary red box over on the right. So in Fabric, we keep these little profiles. So this is sort of like the mini version of the ActiveMQ.xml. So we use this to generate basically an ActiveMQ XML underneath the covers, which you can interrogate at runtime. But you can see like the logical name. So this is broker west, and there's this network equals broker east. So this tells it when I start up the broker, hey, go look in the registry, find all of the brokers in the broker east group, and establish and set up a network connector to them to do store and forward. All I have to do is one line. I don't have to deal with network connectors and all that kind of weird stuff in the XML file. Not that it was that hard, but and I can do things like this kind n+1. So I set this up as an n+1 architecture. So the idea of n+1. So if you guys have played with, so a lot of you played with ActiveMQ. So ActiveMQ master slave, you've got like a 2n architecture. That means for every unique broker I've set up with a persistent store, I have to have 2, a master and a slave, deployed. And so if I started building out a cluster of these, I've got to have 2 per brokers to get the fault tolerance, because I got to have a slave. So that means if I want to set up 10 brokers across my whole data center, where we talked about FAA, they've got 20. Well, that really means they've got 20 active brokers, and they've got 20 passive brokers. They have 40 brokers running. Okay, and half of those are just kind of sitting there going, do I have to become a master? How about now? What about now? Okay, should I do that? So they're just kind of sitting there passive. And you can co-locate on those machines, but they're not actually doing anything. So the idea of n+1 is that I can now, or n+ architectures, is the idea that I can now designate, which is hard to see in the picture. If I go back enough. I don't like the scary red box. So I've created a container, so basically a process running. So I've got an east and a west, but it's hard to see in this picture because they're logical, but there's this broker slave container. So there's one container running that could become either east or west. So this is the +1. So now I've got 2 brokers running and 1 backup. So I've got 3 as opposed to 4, which would be the master slave. And what Fabric is doing is it's got extra smarts so that it says, not only can it become 1, but it actually makes sure that it can't, you can set up this idea of like a standby group. So you can tell it sort of fences off the system. So you can say, I want the slave to become one of these 2, but only 1. So I don't want it to become east and west. If both fail, I don't want it to become both, because that would be bad. Maybe I've capacity loaded this thing, You know, I've got it set up so that for one machine it's good. But I don't want my backup process to become both. That would be bad. So you can specify that. And I can show you later over beers, you know, that this works, and you can play with it, and you can start it and stop it, and it does all the right stuff, which is very cool. And you can do N+2 and N+3 and stuff like that. So you could, if you had 10 brokers, you could say I've got 2 backup, and then, you know, the first 2 nodes that fail, the 2 backups would become those 2, and then the third or whatever become there. But it gives you better control over how you're fault tolerant, so it doesn't become a 2x problem. Just because you're doing it, you can actually manage that. How many machines of failure can I tolerate within my environment? You know, and you can make that decision. If you want full redundancy, awesome, go for it. 2x, great. If you're just saying, hey, you know, I really only need to survive 1 broker failure, and then beyond that, you know, I'm happy for, you know, my pager to start going off and my hair to go on fire and run around. You know, for the second one, you can make that decision, which is kind of cool. Okay. I think the only other thing I'll say, and then I'll hand it over to Scott, who's eager to get back up here and talk, is the downside of this. So this is all very cool for Fabric. So all this cool stuff I talk about is really cool for Fabric managed, Fabric aware systems. So it works for like ActiveMQ, it works for Camel. Camel has as a master component, so you can do the same thing. I can create like a singleton listener endpoint, and I can have it fail over, and I can do all this kind of cool stuff. So that's great for Fabric aware things. But if you've got other stuff that you're trying to manage, databases, web servers, things like that that are not Fabric aware, this does nothing for you. So it's very cool, but it's only for Fabric aware stuff. Now we're trying to, if you did see James's talk yesterday, you know, there's cool things happening in the community. We're going to have Docker containers and microservices, and there's more things that they've got planned, and that's cool, and that'll play out over the next year or so. Very cool, a lot of cool stuff going on, but just right now realize it's not going to help your operations team if they want to use this for helping manage, you know, sort of fault tolerance on multiple other systems. So just be aware of that. Doesn't mean don't use it. It just means it's a balance point. So this is very cool if you're setting up development, maybe QA, dev, production. You can kind of play, you know, or dev, you know, up to production, but then maybe your operation team in production wants to use something else that they're comfortable with. It's just something to think about. Was there a question while Scott comes up and talks about his thing? If you do the logical naming, yes. Because so like with ActiveMQ, we basically use there's a discovery extension. So it's a published mechanism with the Apache ActiveMQ clients. So they have the discovery agents. Multicast is the sort of the more popular and more well-known. It's a bad one, but it's a more well-known one. So we plug into that with Fabric, this Fabric aware thing. So it's an indirection. So yeah, the clients basically have to be aware. You can do some stuff. So the JBoss A-MQ libraries we ship, the client libraries have that agent, so it'll go look it up in the registry if you do the logical name and do the right thing, or the brokers will do the right thing. But if you're using some other generic, you know, now that we support AMQP, if you're using like a generic AMQP client, if it's not Fabric aware, it won't be able to do the logical name lookups. So you'd have to give it specific host and ports. The brokers could still do could use Fabric to do the lock management, to do the federation. It's just the clients have to be aware to do that, and not completely side. There is a gateway concept that's available in Fabric, which is this idea that I can have a process either running locally or on some other machine that just has a fixed address. So it could have like an AMQP listener at some well-known host and port, and then I can have clients connect to that, and then from there, I could use Fabric to map it to a named group. So it allows me to deal with non-Fabric aware clients. I can put up a gateway to say, here's a well-known point for you to connect to. Mm-hmm. But you've got to put that in some place. We're good. We're not that good. We can't reach into things that aren't aware of. Any other questions? And I'll go to Scott. Okay, all yours.
Okay. So I met Scott about 2 years ago, and or a couple years back now, and you know, Fuse had gotten acquired by Red Hat, and I kind of instantly fell in love with ActiveMQ and some of the Camel stuff, and started to see this integration problem, which was really interesting to me. I came from more of a distributed computing background, a lot of automation and web properties that were giant, and that kind of side of things. So I tackled databases and web servers and some of the more general purpose, you know, scenarios that we discussed. And then, you know, in my experience, a lot of our customers, the infrastructure people will tackle the MQ servers because they're also kind of another piece of infrastructure. So I kind of tackled it from that side and looked at how can I possibly, you know, tackle the CAP theorem problem. So consistency, availability, and network partitioning problems, you know, from the Red Hat cluster side or the Red Hat high availability side. So with that, I will kind of start with, you know, Red Hat high availability / clustering is a general purpose clustering tool. And the idea is that there are these failover domains. It's kind of a similar concept to our N+ architecture that we just discussed. What this really kind of demonstrates is an N+ architecture. You can see there are these different failover domains. And you can imagine if there were, you know, each of these failover domains would house, for example, one ActiveMQ service, you know, or maybe several, and they would be able to fail over. You can see the first one could fail between A and B, the second one could fail between B, C, and D, and then, you know, the third one could fail between C, D, and E. And you can imagine you can architect wildly complicated failover domains. It obviously takes that N+ architecture and can go a mile deep as you want to go. And the reason being that, so coming from the distributed computing side of things and tackling CAP theorem and seeing how hard these problems are to tackle, you find that the scenario, you know, the failure scenarios can be quite complicated. And, you know, if you kind of follow more modern paradigms of how to, you know, if you're always going to have unknown problems, something's going to happen, the network's going to black hole traffic in some strange way, you know, and how does even an, you know, an N+ architecture doesn't necessarily help if two of the brokers can't talk to each other. So you end up with this general purpose clustering tool that can go a mile deep, that can do all kinds of checks, like hit a looking glass server that then comes back and checks, make sure the network can actually get to the brokers, things like that. So what happens is when you're, you know, put this thing into production, you'll find some failure scenarios, and you want to keep, every time you find one of those new failure scenarios, you want to, monitor it, you know, and tackle it, you know, model it in your monitoring system, and then model it in some kind of, you know, failover system, be it the Red Hat cluster or inside of, you know, Fuse. So, you know, key benefits of this, it's a general purpose. So when I say general purpose, if you guys come from developer backgrounds, maybe you're not familiar with clustering suites, but they've been around for a long time, probably 20 years, maybe longer even. Honestly, all these sort of CAP theorem problem, you know, solving these things have been around for years. In its simplest scenario, it's basically you're managing processes, mount points, and IP addresses. I mean, that's really kind of the short of it, and that kind of gets it, you know, get your brain wrapped around it. The idea is that you want to move those things around to places where they function, and you want to run tests to see if those function in different places. So again, general purpose, you can use this for a web server, you can use it for an ActiveMQ server, you can, you know, use it for your Camel instances, you can use it for anything. The operations people are going to be more familiar with this type of paradigm, and they can also sort of, you know, model all of those failure scenarios inside of this software, which can go way deeper, you know, from a failover logic perspective. Another interesting thing that isn't quite as true with LevelDB anymore, but, you know, you're completely wildly open to whatever file systems you want to use. So if you can find, you know, better performing file systems, I mean, I don't list others, but there's tons of others. IBM has their own clustered file system. There's a lot of other, you know, file systems and you know, that you might want to use. I didn't even list XFS on here as another one. So you kind of open up to when I can mount and unmount data partitions. You know, when I can mount a piece of storage and unmount it as part of the whole clustering orchestration, I now have a lot of freedom to use whatever I want, not just an NFS4 or a you know, shared storage, some kind like a SAN. And as I mentioned, kind of deeper availability of checks. So as I mentioned, you know, as time goes on, whenever you put something like this into production, you're always going to find some kind of scenario that fails in some way that was counterintuitive to you. And no matter how much planning you did, it will just happen. And as you find those and solve those, you know, hammer those nails down, you want to capture those then and put them into your health checks. So you know, Red Hat cluster has the ability to run an arbitrary script to check something, and so the sky's the limit. When you can run a script to check something and get a yes or a no, you can imagine that, you know, as developers, you can model any kind of logic in those scripts, so you can check for wildly complicated failure scenarios.
Yesterday, or last year, when Scott was talking about this, because of that, in Apache ActiveMQ, they added a health check JMX metric, specifically because of the scenarios that Scott's laying out. So there's actually a JMX metric now that basically gives you a status number that says whether it thinks the broker's like okay, or it's like, hey, you've got producers connected but no consumers. warning,
Warning.
something bad's happening. So there's actually a metrics on it, and that was created specifically because of what Scott was calling out with the need for these scripts. It was because of Scott that Hiram and the other guys did it. So just, you know.
So you can imagine, yeah, and to go even a little deeper, you can imagine that whoever wrote the software, right? I mean, I tackle it from a general purpose clustering perspective, but I love JMX because I can hand that off to Hiram and say, you know how your software breaks better than anyone else. You tell me if it's broken. And so I can go into a JMX, you know, into a little subtree and find a yes or a no. And if it goes no, then fail it over because something's gone wrong. The disk is full, or they're running out of, you know, memory, or who knows what's going on inside of it. But again, I might not be able to. That could take me a lot of pain, you know, years of learning those failure scenarios over time. Whereas he already knows them, you know, and so he can embed that logic inside of the, you know. In fact, I wish everything did this. I wish Apache did that. I wish, you know, Nginx. I wish everything on the planet did that. But with Java, at least they have JMX, so that makes it nice. I just, you know, just a high level, just so you guys at least understand. I mean, with clustering in general, this is true in Linux generally, but I mentioned failover domains. They're a logical way to separate things, you know, or nodes and services in logical ways. Resources are pretty simple IP addresses, again, processes, you know, start, stop processes, move IP addresses around between nodes, and mount and unmount storage, really. And then, you know, fence devices. There's a concept of, so this tackles one of the other weird failure scenarios that people often forget about is randomly a machine will just do nothing, and it will keep the lock, and something will keep running, and nobody knows anything's broken, but you know, your producers and your consumers try to connect to it and nothing happens. You know, those kinds of scenarios, they all be all end all, you know, savior for that is the fence device. So you basically just destroy that machine. You know, you take it and you reboot it, you know, essentially is the way to get rid of that completely. Because when you've got any kind of shared storage, you have a scenario where if two guys can get access to the same data, corruption occurs. So the be all and end all is the fence device. You can just kill the node completely. You can actually reboot virtual machines or destroy them and create a new one. So yeah, in fact, Red Hat High Availability has the ability to go into even a VMware environment and actually tackle restarting a machine, or go into a Red Hat Enterprise Virtualization environment and tackle restarting a machine. So one of the types of fence devices is actually reaching into a, you know, virtualization management suite and telling it, hey, go reboot that virtual machine because it's locked up in some strange failure scenario that we're not sure to even understand. So just reboot it, take it out of the loop, and have somebody else, you know, capture the service and run it. So again, that's kind of, you know, digging in. The cluster manager is what kind of ties it all together, and then that's kind of what does all of the lock managing and all of the magical stuff that even, you know, some of that stuff is built into ActiveMQ, but we have a general purpose, you know, cluster manager, so it can handle all kinds of things. And all the communication between all the nodes. It can be multicast, it can be unicast. There's a whole bunch of deep details in there that I won't go down into, but know that there's a lot of depth and capability there that when you start really seeing some of these failure scenarios in real life, you want to be able to model them. The resource manager is what handles the processes, mounts, and IP addresses. And fencing is what talks to the fence devices and then actually, you know, kills a node and makes it come back up. Conga is the web interface that I was going to show you, that I will show you here. This is actually the new one from RHEL 7, which I have a slide just to kind of show you. I'm not going to demo this one because it's not production, but I wanted a little sneak peek. And then, well, and also notice, one other thing I'd like to notice, like, look, our management tools actually look more consistent. And so I think that's something to point out. If you notice, you look at diffuse, and you'll notice that from some of the other ones. But we are actually making a unified attempt to make all of these things look and feel similar so that when you log into some kind of Red Hat management tool of any kind, it'll at least have some similar look and feel. So with that, I just want to at least show you. So I mean, Red Hat Cluster Suite, it really, what all this models, I will say, I will boil it down, is a config file about this big. You know, probably 25 lines is what this creates in the end, a cluster.conf file. That cluster.conf file has all of this logic. But the web interface, I think, demonstrates it, you know, pretty cleanly. So the idea here is I have a, you know, I want to show you, you have a bunch of different clusters. You can have multiple different clusters. This is the only one I have in here is this AMQ one. And it has three nodes, 3 votes, and quorum. And you can imagine there's all kinds of math you can do to determine what checks you want to have, what votes. And you can imagine you can model very complicated failure scenarios in this. This is a very simple one. There's just 3 nodes, AMQ 0, 1, 2, and 3, or 2, 3, and 4. You can see each of them got 1 vote, and each of them have a separate ID. And then you can see that you run these services on top of it. So I kind of modeled a very similar logic to what he had in Hot.io to this, so that you can kind of see AMQ East, AMQ West, and you can see what node they're running on. And then these are based on the failover domain logic, you can determine what you want it to run on, which nodes you want to allow that to run on. So for example, I do want often, like AMQ East should be able to run on node 2 and node 4, but not on node 3, because I don't want them to collide into each other. And you can see there's failover domain policies here. You can set which failover domain you want to go to. You can determine if you want to restart it in place, disable it. There's a lot of different, again, scenarios you might want. Say there are usage scenarios where if it starts to fail, it's something really bad, and so we just want to stop it, because that's better than even bringing it up somewhere else. There could be scenarios where we need to unwind transactions or something like that. And you can see this is the script it runs. So I can run this arbitrary, CAMQ East script that then does all of the logic, and literally all you do is pass it a status. This cluster suite will pass that script a status as the first argument, and whatever you decide to ship back from that, yes or no. So you can build any kind of logic you want into those scripts. You can go out and hit a JMX connection and say, hey, tell me if you're okay. You can do that and go ping a router and make sure you can actually get out from the node, so you're up. You can build all kinds of logic into those scripts. And then I just want to show you how these resources get kind of, they're little pieces parts. Mount points again. This one is a script, so basically script really starts and stops processes and does all kinds of other magical things. Like I said, you can go check anything you can imagine in the world. You can see the IP addresses, they just fail around between the nodes. So the cluster manager starts and stops those IPs on all the different nodes in the cluster. And that's pretty much the overview of like what a cluster suite can do to kind of add a lot more capabilities. A lot of times you don't really realize that that's what you need until you end up running into the failure scenario. So it's one of those things where you'll go into it and you'll architect what you think is an unbeatable system. It's bulletproof, right? And then I discovered one time that there will be a black hole in traffic somewhere, and I was like, well, I didn't plan for that. So then you start to look at something like this to then figure out, how do I get out of this and actually never let that failure scenario happen again? And with that, I just wanted to at least give you, Scott and I developed a lot of content around this. We have a lot available. There's cluster knowledge base articles. I wanted to kind of talk. There's cluster review process. So these clusters can get wildly complicated. It is encouraged to have Red Hat support look at these clusters before you put them into production. In fact, I would say it's almost mandatory, like right bounding, on the boundary of mandatory. And then another interesting thing that you start to get into with clustering is the concept of stretch clustering. So I didn't want to get super deep into the clustering world, but the idea of stretch clustering is that you will have nodes from the cluster live in 2 different data centers. So you kind of blur the lines between high availability and disaster recovery. And that's really what I think a lot of people want at this point. They want those lines completely blurred. I want it to be able to fail over to another data center without even thinking about it. And I want the cluster suite to handle that for me. So that's kind of where the future of all of this is going. And with that, are there any questions? Does all of this make sense?
You might want to leave the links up, Scott.
Oh, yeah. Sorry.
The ActiveMQ allows you to have that scheduled message. I don't remember.
Scheduled message delivery?
Yeah, that schedule. Does that actually work when you're doing clustering, or does that like dismiss of all kinds of things?
So the schedule message delivery is for one broker instance, and so you can set a timer on when it's going to, deliver a message in the future. So that's on a per broker basis. So there's no clustering capability to that feature.
Where does it save that metadata? Does it save it?
It's in the broker instance itself. So it
so
starts
it's not
up a timer
LevelDB.
instance, and it
Okay.
basically goes. There's like a cron style description that you send out, and I think it uses Quartz internally. Do you know, Ashwin?
The answer is use microservices.
Is it Quartz internally? With the timer message service, do you remember if it's it doesn't matter, but it uses like Quartz, so you use a cron level syntax to say future delivery, but it's only in a particular broker instance. It doesn't cluster across, so we don't have like a shared timer.
So yeah, the short answer is it would break.
Yeah.
But you could have a separate service that does, separate service that is clustered in Red Hat High Availability that does timers and then use the message separate. You know, that's what
Yeah.
I would say if you really need.
Yeah. So I don't think it's something that we fully baked out, but it's something I think there's some effort within the upstream community within Fabric that you would create a separate timer singleton service within a larger Fabric deployment, and it could kick off messages. So it wouldn't be the ActiveMQ futures delivery thing. It would be like a camel route or something that has a timer. You'd kick it off as a singleton process, so it could fail over to other nodes if it needed to, and then it would work with existing brokers that are out there. Does that make any sense?
Yeah, it does actually. I would ask more about that, but that's not really an ActiveMQ thing. We're into like,
Yeah, but so there's some. That's why I said so. Fabric has got some interesting things from a developer perspective. There's some really interesting things that it's coming in that can allow developers to do some really interesting kind of scenarios around failure on that. And within like Camel, I mean, kind of going over ActiveMQ, but there's a master component which allows you to tap into the lock management capabilities of Fabric, just like ActiveMQ is tapping into it from Fabric. So you can start to build out kind of more interesting architectures to deal with like that featured message delivery. Hey, I can't depend on ActiveMQ doing it, but if I pop it out, I could build something else that's kicking it, like a job scheduler that kicks it off and does some interesting things. But that works great in Fabric Aware system, and as Fabric 8 kind of keeps going, I think there'll be some really interesting things coming out of that. But then it's sort of the balancing it with what your operations team needs in terms of the comfort, and as well as also tying into like, hey, what about the network? What about storage devices? What about this? You know, when I lose connectivity or that storage device becomes unresponsive, what the hell do I do then? And it's harder for Fabric 8 to react to that, whereas these cluster suite technologies can handle that. So it's sort of, you can find, and they can work together.
Yeah.
You know, when we built out this demo last year, which is what Scott's got documented in the resilient messaging, his blog, he talks a lot about the scripts and other things on that. They can work together, so you can use cluster suite combined with a Fabric-based deployment.
To make a super cluster.
So you can kind of poke at Fabric to do this, but you're not having Fabric actually deal with the device or the fencing. So you could let the cluster suite technology deal with that really well, and then let Fabric 8 kind of have your elastic application development. So you can kind of mix and match.
Yeah, because when a node dies, you still want to come back online, and cluster can handle all that stuff for
So
you.
they're not mutually exclusive. You can actually do complementary, but you just have to be aware that there is overlapping capabilities, and you just need to be careful about where you put them. So, yeah.
So I didn't show you cluster.conf. I should have brought it up as maybe, but essentially it just tells it what script to run, and that script lives in the file system. And so when you have a cluster, say 100 servers, you would have that script on all 100 servers, you know, probably version controlled in some way. And then you could make changes to it if you wanted. But I mean, that's a dangerous game to play. You would definitely want to test that very well. And these are hairy tests because they are temporal in nature. So it does run it every so often, like 30 seconds, or you can set it to whatever you want to get it run at 5 seconds. Obviously that gets pretty hairy when you have really complicated checks. And I could go down that rabbit hole of distributed computing, but the problem is some of those checks, you want them to be simple enough that they can run quickly and execute within a small enough time frame that you know that the service is actually up within your SLA. You don't want something that takes 10 minutes to run. You're like, well, it's up. Oh, let's start another one 10 minutes later. I've written some really hairy ones where I'll even run really complicated checks, save the results in the file, and the check basically just kicks it off asynchronously and then writes the data to the file, and all the health check does is to return that data from that file, because you need that data quickly, but you might want to get refreshed, you know, whenever it can be refreshed, you know. So I've done some hairy things like that. And then the one little final thing we did not really dig into it, but the MQTT and the AMQP, that's where another place where the clustering comes in place. So the Internet of Things, as we like to all talk about. You get into that scenario, you've got all these lightweight devices, they're not going to be part of the fabric, so you need some other way to handle, at least that entry point into the fabric. You know, even. So they definitely can work together.
You have a question?
I saw no.
So So some people do that. Some will do. So we've got there's some customers that built like foreign exchange trading applications on ActiveMQ. So they've got New York, London, Hong Kong trading centers. So they might deal with particular data centers. They're going to want to try and get locality. So if it's New York Stock Exchange trades, they're going to kind of keep them in the New York data center. But they might have some data that the other, like London, wants. So they're going to do on-demand forwarding to that. So that's why they'll have a network connector to another data center. Or in that scenario, they might also have, if a local processor, if a consumer, a message consumer in that, say, New York data center, to stick with that example, dies, so it's not pulling messages off that queue, you can set up waitings in ActiveMQ so that I can say, give priority to local consumers, consumers that are directly connected to me. But if that dies, I still want those messages processed within some SLA, so I could have a consumer on a remote broker, say in the London data center, that would start picking those messages up. So at least they'll get processed, and then when the consumer connects back locally, it'll get priority again. So there's scenarios where they're not complete disaster failures, but it's sort of I need to know that these messages are processed, and I want to try them do it locally. Maybe I want to go remote. In the foreign exchange trading applications, they actually built out redundant data centers. So they had sort of 3 primary data centers and 3 failover data centers, and they would test failure scenarios there. Those get more complicated because they had to actually expose that up to the application level, because they basically want to be able to flip a switch and it's like kill off a data center and bring up another one. So the applications have to be aware of that. FAA's case, the applications are aware of failures, if that makes any sense. So we're not just depending on, hey, the broker just magically flips over. The applications actually have to have some visibility to it, because otherwise you miss polling windows. If the brokers fail over, you've got this window where, like I said, with the distributed file lock management, the slave is actually polling on a periodic basis to say, can I get the file lock, can I get the file lock? If you've got like a 30-second SLA to ensure a message gets delivered, well, you can't, if you've got a couple of these polling windows in there, you've missed your window. So you've got to build some more logic in. But those are pretty extreme. I mean, there's only a handful of customers I've seen with that sort of extreme, message must be dealt with in 30 seconds, even if I lose a whole data center. Those are rare.
But I was going to say the more general purpose one that I see commonly, though, is you get into a cloud environment, you're looking at availability zones. And so what does it mean for a data center to fail? I mean, we're building services architectures anyway. So you're like, well, the MQ server went down. Let it do whatever it's supposed to do when that availability domain goes away. When that availability zone dies. And that happens all the time in Amazon. So you need to plan for that. So that's why people want that. I mean, even in fairly simple scenarios, you need to plan for that.
Did we answer your question? I don't know if we overcomplicated it, but there's reasons that people will do that, or just even maintenance. I've also seen customers that just, they'll take down, we're going to do network. There's network maintenance happening in data center A. And they're like, ooh, no, bad things have happened when we've done that. So they basically shut down the data center. They fail over to the other one so they could do local maintenance, because they've seen weird things happen. Oh, the network, oh no, it's just isolated to this router. We're just fixing it. It won't do anything to the rest of your world. Yeah, no. So they fail it over intentionally. So that's why they'll have multiple data centers, is that they're like, yeah, any significant maintenance, we're not trusting that in the larger deployments. So any other questions?
I think all the concepts are still very relevant, although Windows has its own clustering mechanisms that are quite similar.
Yeah.
I mean,
same principle. I mean, you're not going to use Red Hat high availability for that, but other clustering technologies, including, I forget what Microsoft's is called, but you can use those as well. It's the same idea, the same concepts in terms of ActiveMQ. There's you have to designate a process as master. It's either depending on a file lock or a database, or something is controlling, starting up the process. And I know with Microsoft that their clustering technology has the ability to say, this machine is now dead. I'm going to start up processes and do other things on this other failover machine. It's the same concepts, but with ActiveMQ, you just have to make sure that only one process is accessing a data directory, its persistent store at one time. And however you set that up with Windows or Linux or whatever, the same idea. You just have to pick different technologies, but all of the same high-level concepts are identical. So
we actually had a customer do that in my patch.
Yeah, no, we've had a bunch of customers that have used Windows clustering and other stuff with ActiveMQ. So, and Fabric would certainly work in that scenario. So Fabric would work anywhere. on that environment. So it would help in that front.
Just a comment, I got the email notification that 6.1 is available.
Cool.
Hey, and now it's official. Woohoo! Even though I slipped, you know, I wasn't. You didn't hear it from me though. Awesome.
That's official.
Awesome. Yeah. No, I downloaded it this morning, so it's like, you know, that's what I was demoing. I should have said that. I was demoing 6.1, actually the GA release. So, cool. Well, good. Thank you very much.
Yeah.